Lagrange mean value theorem. This we need to do without proof. The statement is fx is a function defined on is a function defined on closed interval a b such that one fx is continuous on open closed interval a b. Second, f dash x is derivable on open interval a b, then there exists a c some point belonging to a comma b greater than a less than b, such that f dash c is equal to fb minus fa upon b minus a. This is the definition of this part of this Lagrange. This is the statement of Lagrange. You don't need to go into the proof of this. No need of the proof. Now on this, supposing I take one point here to discuss. The point that I want to discuss is just a minute. Here it is. Look at this. Look at this only. That would do the job for me. Now suppose this is note one. Note one. This is the note one that I want to write. Note one is that if f satisfies uh, LMVT, the Lagrange mean value theorem. This is the shortcut. Lagrange mean value theorem. This is the shortcut. And if f dash x is 0, then for all x belonging to open interval a b, then fx is constant. Then fx is constant. Suppose I take 2 points, x1 and x2, belonging to AB. Suppose I take this belonging to A comma B, such that x1 is less than x2. x1 is less than x2. And since this function satisfies Lagrange's theorem, since this function, I'm already telling, मैं बोल ही रहा हूं कि function satisfy कर रहा है Lagrange theorem. Therefore, since it's satisfying, I have to show that f is constant. I have to show f is constant. So the proof is, answer I should say rather here. The proof is, basically what is the situation is here like this. This is A for your understanding. This is x1. This is C. This is x2. This is B. Something like this. Actually it is something like this. ये कुछ ऐसा है situation. Satisfies Lagrange theorem, or f dash x is 0 for all x between a b. See, for all x between a b, then f is constant. For that उसके लिए I'm selecting x1 and x2 which are inside a b, and such that x1 is less than x2. And I will select a point since this function satisfies Lagrange. So there is a point C, f dash c, or let us say this c is arbitrary point, so we can call it x also, no problem. If I call it x, no problem. Let me call it x. That would be a better option. Let me call it x. This is that x point. This is behaving like this. X point is behaving like c. ये जो x point है ये behave कर रहा है c के तरह. So f dash x is equal to f of x2 minus f of x1 upon x2 minus x1. This they are saying. We have a point, see, in the theorem we have a point. This in theorem में हमको खाली बस ये बात है. Look, this point c is this point c is in between AB. This point C is in between AB. I have here considered that fx satisfies Lagrange mean value theorem and f dash x is 0 for all x belonging to this. Then f is constant. Suppose I take any 2 points between AB such that x1. So this behaves somewhat like this, and this C will now behave like X. Now with like this C will behave like this C. This C which is in between. Now the point is x1 and x2, and this x1 and x2 is inside AB. ये जो point x1 x2 है, ये कुछ ऐसा है situation. Look, make it more clear for yourself. See, this x is in between open interval x1 x2, which is contained in the complete open interval AB. This is the actual thing. This is the actual idea basically. Now this is given to be zero. This is zero as f dash x is zero. Therefore, fx2 minus fx1 upon x2 minus x1 is 0, implies fx2 equal to fx1 for all x1 x2 like this, for all x1 x2 like this, for all x1 comma x2 comma x2 belonging to a comma b, belonging to a comma b. So f is constant, therefore f is constant. समझने की कोशिश करो हमने क्या किया. What I have tried to do, see, basically I have this C inside AB. This is the statement. F dash C is FB minus FA by B minus A. Now I am saying that F satisfies Lagrange mean value theorem. That means this condition holds. This condition holds. And I am trying to show that if this situation, F dash X, this X is behaving exactly like this C. That is F dash C is becoming 0. Then I'm trying to show that f is a constant. F is constant function basically. Suppose I select x1 x2 between a b such that x1 is less to, so the thing will be like this. A would be less than x1 will be less than this point. This x is behaving like C. So x2 less than b. Now the thing is, this f dash x is equal to fx2 minus fx1 upon x2 minus x1, because this is behaving like C. This is behaving like C, and I have the point x1 and x2 interval. So x2, x1 and x2 minus x1. Now this x is belonging to x1, x2 because because of this concept. X is inside x1, x2. Therefore, I will use for x1, x2. This concept I will use for x1, x2. The way I use the concept of this for between A and B. So now if you see this f dash x is given to be 0. So this whole quantity becomes 0. This whole quantity becomes 0. That means fx1 equal to fx2 for all x, for all x1, x2 belonging to AB. So this is always constant for all values of x1, x2. And x1, x2 are arbitrary. Therefore f is constant. समझने की कोशिश करो ऐसे करके इसको. देखो यहाँ पे एक C है जो A और B के बीच में और इस कंडीशन को होल्ड करता है, इस कंडीशन को f डैश सी. तो मुझे प्रूव करना है कि अगर f लैग्रांज मीन वैल्यू थ्योरम को सेटिस्फाई करे, लैग्रांज मीन वैल्यू थ्योरम को सेटिस्फाई करे और f डैश x 0 है फॉर ऑल x, ये सबसे बड़ी बात है, फॉर ऑल x, सभी x के लिए बिटवीन a एंड b, देन f इज अ कांस्टेंट. मैंने मान लिया x1 x2 a b के बीच में है और x1 x2 से कम है, ऐसे करके कम है कि ये एक मिनट, ये a जो है x1 से छोटा है, ये x ये बिहेव कर रहा है c की तरह, जो ऊपर ये जो c है ना इसकी तरह बिहेव कर रहा है, और ये x2 है b से कम. नाउ मैं अप्लाई कर रहा हूं, ये जो कंडीशन था यहाँ पे मैंने x1 लिख दिया और यहाँ पे मैंने x2 लिख दिया और यहाँ पे मैंने x लिख दिया, तो ये क्या बन गया, f डैश x is equal to fx1 fx2 fx1 and then x2 minus x1, same what I have written here. Now this x is in between this and this is, and f dash x is already 0. F dash x is already 0, so therefore this is always 0, and this is therefore this cross multiplication will give me 0. So fx1 equal to fx2, and therefore for all x1, so f is a constant. Now see one thing. Now from this I can make one very important conclusion. Also, a very next conclusion is number 2 conclusion. Note 2. That is, if fa equal to fb fa equal to fb, in that case f dash c would be 0, which is a special case of this becomes, then this becomes Rolle's theorem. This becomes Rolle's theorem. Because if you look at this, agar yahan dekho, if you look at this, if you look at this case, in this case, if FB and FA are same, that is the third condition of Rolle. If they become same, then f dash c is 0. इसके साथ कंफ्यूज मत करना कि ये f dash 0 है बोल के यहाँ पे ये बराबर हो गया. Don't confuse with this condition. This is a totally different case, and this the case I am discussing here is different. Here I have taken f dash x as 0. I have taken this side as 0. Sorry, I have taken this side as 0, right? I have taken this side as 0, but here in this situation I am taking the right side equal, this side equal, so they two are totally different conditions. यहाँ पे मैंने इस केस में, इस वाले केस में मैंने इधर वाले साइड को जीरो लिया है, इधर वाले साइड को, ये देखो इधर वाले साइड को जीरो लिया है, जिसके कारण ये कांस्टेंट आया है. और इस केस में मैंने क्या किया है, इस केस में मैंने इधर वाले साइड को बराबर किया है, जीरो नहीं किया, ये दोनों को बराबर किया है. तो एफ डैश सी जीरो हो गया. वो कंडीशन, थर्ड कंडीशन ऑफ रोल्स थ्योरम सेटिस्फाई हो रहा है. अगर एफ ए इक्वल टू एफ बी हो जाए तो थर्ड कंडीशन ऑफ रोल्स थ्योरम में कन्वर्ट हो जाएगा. Now, the third point, note number three. Now, you know, already I have seen that f dash c, suppose any 2 points, I took f dash x equal to fx2 minus fx1 for x2 minus x1 in this condition above, where I took x belonging to x1 comma x2, which is a subset of, say, a comma b. Then supposing, look, f dash, अगर f dash x greater than 0 है, जो increasing function का condition होता है, greater than 0 है, if f dash x is greater than 0, then this whole quantity becomes greater than 0. See, this quantity becomes fx2 minus fx1, fx2 minus fx1 upon x2 minus x1 becomes greater than 0. This implies, cross multiply this with this 0, so fx2 minus fx1 is greater than 0, implies, and I have taken the condition x1 is less than x2. So I am saying fx2 is greater than fx1. This is same as writing as rather I should write it this here, not there. Wait, this one, rather this one is same as fx1 is less than fx2. x1 less than x2 gives me fx1 less than fx2 for this condition. This was the condition I told you earlier in my video of increasing and decreasing, that this is a increasing function. So this is also a second condition. If x1 and x2 is less than, x1 is less than x2, and gives me fx1 and fx1 less than fx2. Let me write it once more and then explain you the thing. See, x1 less than x2 gives me fx1 less than fx2, then f is increasing. Rather, f is increasing if and only this condition happens. Implies, wait a minute, if and only if f is increasing. F is increasing function. Listen again. Let us understand this concept once more. I gave you this condition. F dash x is this. I have taken this already, which I explained in this problem. This here, what I explained you here, this part, I have taken in this manner here. I have taken this fx, f dash x is this, where x is in between the same condition. Now I've taken x1 is less than x2. And I know for increasing function, f dash x is greater than 0. I know already that f dash x is greater than 0. That means fx2 minus fx1 upon is greater than 0. That is fx2 minus fx1 is greater than 0 implies fx2 is greater than x1. This is same as, which is same as saying, let me write same as fx1 less than fx2. So what I got for x1 less than x2, for x1 less than x2, I got fx1 less than fx2. If and only if f is increasing. See, if this condition holds, then f is increasing. And if f is increasing, then this condition will hold both ways. Both ways. Now let us see for the decreasing one. For the decreasing one, this should be less than 0. Decreasing के लिए ये 0 होना चाहिए, less than 0 होना चाहिए. देखो हमने क्या किया, ये हमने डिफाइन किया कैसे, x लिया हमने x1 और x2 के बीच में, that is between a and b. Now I have already taken x1 is less than x2. अब मैंने already x1 को x2 से less लिया था. And in the definition of increasing function, I have told you f dash x is greater than 0. मैंने बताया था f dash x is greater than 0 in the definition of increasing function. So therefore, इसीलिए ये पूरा quantity greater than 0 होगा. This quantity will be greater than 0. This quantity is greater than 0. Cross multiply this with this, this with this, this with this. So this will become 0. So fx2 minus fx1 will be greater than 0. So fx2 is greater than fx1. So fx1, let me write it, fx1, yes, completely. And which is same as fx1 is less than fx2. Combining the result, इस result को और इस result को, ये result बोलो, you call this result or you call this result one and the same thing. So x1 minus x1 less than x2 gives me this, if and only f is an increasing function. So we see that there are two definitions of an increasing function. Number one definition was this. This is same as f dash x is greater than 0. See, one definition is this, the other definition is this of an increasing function. This is the other definition. ये एक definition है, ये दूसरा definition है increasing function का. Sometimes you will use this, sometimes you will use this. That does the job. अच्छा, अब for decreasing function, f dash x would be less than 0. We are taking that idea constant, always same. That is, x1 is less than x2. I'm taking this always included. x1 is less than x2. So now for f dash less than 0, f dash less than 0, fx2 minus fx1 upon x2 minus x1 is less than 0. This will give me fx2 minus fx1 less than 0, which will give me fx2 less than fx1. For what? For which one? For this very condition. For this case. For this case. This case. For this case, I am getting, let me write it that there also. Let me write it here also. I am taking f dash is less than this, this is this. I am taking x1 is less than x2 here also, the same condition. So x1 less than x2 implies fx2, fx1, or I write fx1 greater than, or you write it this way, fx2 less than fx1, then if and only if f is decreasing function, decreasing function, f is decreasing function. That is like saying this, if I say this was same as f dash x less than 0. देखो x1 लेस देन x2 तो मैंने मान ही रखा है, तो f dash x अगर लेस देन 0 होगा तो ये क्वांटिटी लेस देन 0 होगा. So this is less than 0. So this is one condition. So one condition of decreasing function is this, the other is this. At times you will use this, at times you will use this definition.